Deployment of killer whale unmanned warship technology by 2025. Overview. The killer whale unmanned warship technology is poised for deployment by 2025, a strategic initiative aimed at modernizing naval warfare through advanced AI and autonomous navigation systems. The initiative is structured into a four-phase integration process supported by a budget allocation of $150 million specifically earmarked for the development of these cutting-edge technologies. Integration phases and timeline. Phase 1 2023, Initial Development and Testing. The journey towards the deployment of the killer whale technology began in 2023 with the initial development and testing of unmanned warship prototypes. This phase was crucial for establishing the foundational capabilities of the warships, including basic navigation, developing systems that allow the warships to navigate independently in maritime environments, communication functionalities, ensuring reliable communication channels between the unmanned vessels and command centers. During this phase, prototypes were subjected to preliminary tests to assess their performance under controlled conditions. Feedback from these tests was integral to refining the technology and addressing any initial challenges. Phase 2 2024, Advanced Testing in Complex Environments. The second phase commenced in 2024, focusing on advanced testing in more complex maritime environments. This phase was characterized by rigorous evaluations. Unmanned systems underwent extensive evaluations to test their reliability and effectiveness in combat scenarios simulating real-world challenges. Partnerships with defense contractors. Collaborations with defense contractors and technology firms were established to enhance AI algorithms and navigation systems, leveraging expertise and resources. These efforts aim to ensure that the unmanned warships can operate effectively in diverse and challenging conditions, preparing them for the demands of modern naval operations. Phase 3 early 2025, Full integration of AI systems. As the project progressed into early 2025, the focus shifted towards the full integration of AI systems into the killer whale technology. This phase included autonomous decision-making. The warships were equipped with the capability to make autonomous decisions based on real-time data analysis, significantly enhancing operational efficiency. Operational readiness. Comprehensive simulations and live exercises were conducted to validate the technology's capabilities, ensuring that the unmanned vessels are prepared for deployment. This phase was critical for addressing any final adjustments needed before the technology could be fully operational. Phase 4 mid to late 2025, Official rollout and training. The final phase is set for mid to late 2025, where the killer whale unmanned warships will officially enter active service. Key activities during this phase include official rollout, deployment of the unmanned warships into operational theaters, marking a significant milestone in naval warfare capabilities. Training for personnel. Extensive training programs will be implemented for personnel on operational protocols and maintenance, ensuring that all team members are well prepared to work with the new technology. Key themes and insights. Several key themes emerged from the analysis of the deployment process. Budget commitment. The allocation of $150 million underscores a strong commitment to advancing AI and autonomous systems within naval operations, highlighting the importance placed on technological innovation in defense. Focus on AI and autonomy. The integration of sophisticated AI technologies is emphasized as essential for enhancing decision-making capabilities and operational efficiency in naval engagements. Importance of testing. Extensive testing is recognized as a critical component to ensure that the unmanned systems can function effectively across a variety of environments and scenarios. Variations in sources. Despite the commonalities, variations in perspectives were noted among different sources. Urgency and concern. One source expressed a sense of urgency regarding the deployment process, suggesting potential implications for national security and operational readiness. Technical and operational focus. Other sources concentrated more on the technical aspects of the integration, discussing the specifics of the AI and navigation systems. Sustainability goals. A third source shifted focus to broader sustainability goals, indicating the multifaceted nature of modern defense technology initiatives. Potential use cases. The killer whale technology offers a range of potential applications within naval operations, including maritime surveillance. Unmanned vessels can conduct reconnaissance and monitoring over vast oceanic territories, significantly reducing risks to human personnel. Logistics and resupply operations. The use of unmanned ships for logistics can facilitate supply missions to naval forces without exposing crew members to hostile environments. Combat operations. The technology could be deployed in combat scenarios, allowing unmanned vessels to engage enemy assets while minimizing human casualties. Conclusion. The deployment of killer whale unmanned warship technology by 2025 signifies a transformative step in military capabilities, leveraging advanced AI and autonomous navigation systems to enhance naval warfare. The structured four-phase integration plan, supported by a substantial budget, aims to ensure that these unmanned systems are operationally viable and effective in modern combat scenarios. This initiative reflects a broader trend in defense technology toward automation and intelligence-driven operations, underscoring the evolving landscape of military engagements in the 21st century. The deployment of the killer whale unmanned warship technology by 2025 involves a structured four-phase integration process with a significant budget allocation of $150 million for the development of AI and autonomous navigation systems. While the information presented outlines a clear plan for the integration and deployment of this technology, several counterintuitive points arise when examining the broader implications and the details of the deployment process. Counterintuitive information. 1. Cost efficiency versus high budget. At first glance, a $150 million budget allocated for AI and autonomous systems may appear substantial. However, when juxtaposed with traditional military expenditures for manned vessels, this budget could be perceived as cost-efficient. The initial investment in unmanned technology might lead to long-term savings by reducing personnel costs and minimizing risks associated with human lives, challenging the notion that advanced military technology must always come at an exorbitant price. 2. Autonomy and decision-making. The integration of AI systems enabling autonomous decision-making could raise concerns about accountability and ethical implications in combat scenarios. Traditionally, military operations involve human judgment to assess situations and make critical decisions. The transition to autonomous systems could lead to a paradox where increased efficiency in decision-making might result in unexpected outcomes such as escalation of conflicts without human oversight. This shift challenges the intuition that more automation inherently leads to better control over military engagements. 3. Public perception of unmanned warfare. The deployment of unmanned warships might be seen as a move toward minimizing human casualties in warfare, potentially leading to a more favorable public perception of military actions. However, the reality may be quite the opposite. The use of autonomous systems can desensitize the public to the realities of war, as the absence of human operators may create a psychological distance from the consequences of military actions. This could foster a permissive attitude towards military engagements, contradicting the expectation that reducing human involvement would lead to more cautious military behavior. 4. Sustainability and technological integration. While some sources hinted at broader sustainability goals, the integration of advanced technology in military applications typically raises questions about environmental impacts. The development and deployment of unmanned vessels could lead to an increase in resource consumption and electronic waste, challenging the notion that military advancements inherently align with sustainability objectives. This dissonance highlights a counterintuitive aspect of technological progress in defense. While aiming for efficiency and effectiveness, the environmental implications may be overlooked. 5. Complexity of maritime environments. The plan emphasizes rigorous testing in complex maritime environments, which may suggest that the technology is inherently reliable and ready for deployment. However, the reality of maritime operations involves unpredictable conditions that can significantly hinder autonomous systems. This complexity raises doubts about the reliability of AI in real-world scenarios. Countering the expectation that advanced technology can seamlessly adapt to challenging environments. 6. Potential for increased conflict. The introduction of unmanned combat vessels might be perceived as a deterrent against adversaries due to reduced risks for human operators. However, the availability of autonomous systems could also lower the threshold for engaging in military actions, as the political cost of deploying unmanned vessels might be perceived as less severe than that of manned operations. This perspective contradicts the assumption that technological advancements will lead to a more peaceful approach in military strategy. 7. Training and operational challenges. While the final phase of deployment includes training personnel on operational protocols, there may be an assumption that integrating technology will be straightforward. The reality is that transitioning to unmanned systems requires a significant shift in military training and operational frameworks. This adaptation process could create initial inefficiencies and challenges that counter the expectation of immediate operational readiness. Conclusion. The deployment of killer whale unmanned warship technology by 2025 embodies a pivotal shift in military capabilities driven by advanced AI and autonomous navigation systems. However, the counterintuitive aspects of this integration process highlight the complexities and potential repercussions of relying on unmanned systems in warfare. While the initiative aims to enhance operational efficiency and reduce human risk, it simultaneously raises ethical, operational, and societal questions that challenge conventional wisdom about the future of military engagements. The integration of such technology is not merely a technical challenge but also a profound transformation in how military operations are conceived, conducted, and perceived by society. The report on the deployment of killer whale unmanned warship technology by 2025 outlines a structured approach to integrating advanced military technology which is poised to significantly alter naval warfare. While the document provides a comprehensive overview, several important aspects are likely to be overlooked, but they bear substantial significance for understanding the broader implications of this initiative. 1. Investment focus on AI and autonomy. One critical point that may not receive sufficient attention is the dedicated $150 million budget for AI and autonomous navigation systems. This allocation signifies more than just financial investment. It reflects a strategic pivot towards embracing cutting-edge technologies that can redefine combat and operational strategies. The emphasis on AI suggests that future naval operations will increasingly rely on data-driven decision-making processes, minimizing human error and enhancing responsiveness in dynamic environments. Significance: in an era characterized by rapid technological evolution, the focus on AI can lead to a competitive advantage over adversaries who may not adopt similar innovations. This could shift the balance of power in naval conflicts, making it imperative for rival nations to accelerate their own technological advancements. 2. Phased integration and testing. The structured four-phase integration plan is another aspect that deserves deeper analysis. Each phase serves a specific purpose, from foundational development to full operational readiness. Particularly, the robust testing in complex maritime environments during Phase 2 is essential for validating the system's capabilities under real-world conditions. Significance: the detailed testing phases are crucial for identifying potential weaknesses in the technology before deployment. This mitigates risks associated with unproven technologies in combat scenarios. Furthermore, the iterative nature of the testing process allows for continuous improvement and adaptation, which is vital in an unpredictable maritime landscape. 3. Partnerships with defense contractors and technology firms. The report mentions partnerships with defense contractors and tech firms during Phase 2, which is a vital element of the integration process. These collaborations are not merely administrative, they can significantly enhance the innovation pipeline, enabling the incorporation of the latest advancements in AI and autonomous systems. Significance: the involvement of external expertise ensures that the Killer Whale project benefits from diverse perspectives and cutting-edge research. This approach can accelerate the development timeline and improve the quality of the end product, thereby increasing the operational effectiveness of the unmanned warships. 4. Potential use cases beyond traditional combat. While the report outlines potential use cases such as maritime surveillance, logistics, and combat operations, it's essential to consider other applications of this technology that may not be immediately apparent. For instance, unmanned warships could play a crucial role in humanitarian missions, environmental monitoring, and search and rescue operations. Significance: expanding the narrative around the use of unmanned vessels beyond military applications can foster public support and acceptance. Additionally, it opens avenues for collaboration with non-defense sectors, enhancing the technological ecosystem and potentially leading to innovations that benefit both military and civilian domains. 5. Long-term strategic implications. The report primarily focuses on the immediate deployment timeline and technical specifications, but it is equally important to consider the long-term implications of introducing such advanced technology into naval operations. The integration of autonomous systems could lead to a fundamental transformation in naval tactics training and international maritime law. Significance: as unmanned vessels become more prevalent, the rules of engagement and the legal frameworks governing naval warfare may need to evolve. This could lead to international discussions around ethical considerations, accountability in autonomous operations, and the implications of reduced human presence in combat scenarios. These discussions are crucial for establishing norms and guidelines that govern the use of AI in military contexts. 6. Public and ethical concerns. Despite the technological advancements, there may be public apprehension regarding the ethical implications of deploying autonomous military systems. The potential for autonomous warships to engage in combat raises questions about accountability, decision-making in life-and-death situations, and the possible escalation of conflicts without human oversight. Significance: addressing these ethical concerns proactively is vital for maintaining public trust and support for military initiatives. Engaging with stakeholders, including ethicists, policymakers, and the general public, can help navigate these challenges and develop frameworks that ensure responsible use of AI in warfare. 7. Impact on military workforce and training. The introduction of unmanned warships will inevitably impact the naval workforce, necessitating changes in training and operational protocols. Personnel will need to adapt to new roles that may involve overseeing autonomous systems rather than traditional hands-on operations. Significance: understanding how the integration of autonomous technology alters job functions within the military is crucial for workforce planning and development. Training programs must evolve to equip personnel with the necessary skills to operate in a technology-driven environment, ensuring that the human element remains integral to naval operations. Conclusion. In summary, while the report on the Killer Whale unmanned warship technology provides valuable insights into the deployment timeline and technical aspects, the broader implications of this initiative warrant closer examination. Understanding the significance of AI investment, the phased integration approach, partnerships, ethical considerations, and long-term strategic impacts can offer a more comprehensive perspective on how this technology will reshape naval warfare and military operations as nations navigate this new landscape. The lessons learned from the deployment of unmanned systems will be crucial in defining the future of military engagements and international security. 1. Structured integration process. The deployment of the Killer Whale unmanned warship technology involves a well-defined four-phase integration process. This systematic approach is crucial for ensuring that the technology is developed, tested, and implemented effectively. Each phase builds on the previous one, from initial development and testing to full operational deployment. This structure allows for incremental improvements and adjustments based on real-world testing and simulations. which is vital in military applications where reliability is paramount. 2. Significant budget allocation for AI and autonomous systems. The project is backed by a dedicated budget of $150 million specifically aimed at developing artificial intelligence and autonomous navigation systems. This financial commitment underscores the importance of advanced technology in modern naval warfare and reflects a strategic investment in capabilities that can significantly enhance operational efficiency and decision-making in combat scenarios. The focus on AI and autonomy is indicative of a broader trend in military modernization prioritizing technology that can operate effectively in complex environments. 3. Emphasis on multifaceted testing and reliability. Extensive testing is a core theme throughout the integration phases, particularly in Phase 2, where unmanned systems will undergo rigorous evaluations in complex maritime environments. This emphasis on testing is critical to ensure that the warships can operate reliably and effectively in various conditions, including potential combat scenarios. The ability to adapt and respond to real-time data analysis will be crucial for operational success, making thorough testing a significant point of discussion. For potential use cases and strategic implications, the killer whale technology holds several strategic use cases, including maritime surveillance, logistics and resupply operations, and direct combat engagements. These applications demonstrate the versatility of unmanned systems in enhancing naval capabilities while minimizing human risk and exposure to hostile situations. The strategic implications of integrating such technology into military operations could reshape naval warfare, making it more efficient and less reliant on human personnel, thereby transforming traditional military strategies and engagements. 1. Project Maven 2017-present. Project Maven is a U.S. Department of Defense initiative aimed at integrating artificial intelligence into military operations, particularly for processing and analyzing drone footage. The project highlights the military's growing reliance on AI to enhance surveillance and data analysis capabilities. Initial phases included partnering with tech firms like Google to develop machine learning algorithms that can identify objects in video footage, thereby increasing the effectiveness of drone missions. The project has sparked debates around ethical implications and the use of AI in warfare, similar to concerns surrounding the deployment of unmanned warships. 2. DARPA Sea Hunter Program 2016-present. The Defense Advanced Research Projects Agency DARPA launched the Sea Hunter program to develop an unmanned surface vessel intended for anti-submarine warfare and intelligence surveillance and reconnaissance missions. The Sea Hunter is designed to operate autonomously, utilizing advanced navigation systems and AI to conduct missions without human intervention. The program has undergone multiple testing phases to refine its capabilities, focusing on operational efficiency and decision-making processes, akin to the phased integration approach for killer whale technology. 3. NATO's Allied Command Transformation ACT and Enhanced Navy Capability Initiatives 2010-present. NATO has been working on enhancing naval capabilities through various initiatives, including the integration of unmanned systems and AI in maritime operations. The ACT emphasizes the importance of adopting advanced technologies to improve situational awareness, decision-making, and operational readiness among member nations. Various phases of development and testing have taken place to ensure that these technologies can be effectively integrated into existing naval operations, resembling the structured deployment plan for killer whale unmanned warships. Future outlook: deployment of killer whale unmanned warship technology by 2025. The deployment of the killer whale unmanned warship technology by 2025 signifies a transformative step in naval warfare and maritime operations. The integration of advanced artificial intelligence, AI, and autonomous navigation systems is poised to reshape the capabilities of naval forces, enhancing operational efficiency and reducing risks to personnel. 1. Predictions for technological advancements. By 2025, we anticipate significant advancements in AI and autonomous systems driven by ongoing research and development. The killer whale program will likely incorporate machine learning algorithms that enable the unmanned warships to adapt to various maritime environments in real time. This adaptability will enhance their effectiveness in surveillance logistics and combat operations. Moreover, as AI technologies evolve, we can expect improvements in decision-making processes, allowing unmanned vessels to assess threats and execute missions with minimal human intervention. The integration of sophisticated data analytics will enable these vessels to learn from previous missions, enhancing their operational effectiveness over time. 2. Operational impact on naval forces. The introduction of killer whale unmanned warships will fundamentally change the operational dynamics of naval forces. We predict that increased operational range, unmanned warships will extend the operational range of naval forces, allowing for sustained missions without the need for immediate human oversight. This will be crucial for maritime surveillance and reconnaissance, especially in contested regions. Cost efficiency. The ability to deploy unmanned vessels for logistics and resupply operations will lead to significant cost savings. With fewer personnel required for dangerous missions, naval forces can allocate resources more effectively, potentially reallocating funds to other critical areas of defense. Risk mitigation. Unmanned systems will reduce the risk to human life in combat scenarios. By allowing unmanned ships to engage in direct combat or surveillance missions, the military can minimize casualties while maintaining operational effectiveness. 3. Strategic military advantages. The deployment of killer whale technology could provide strategic advantages in naval warfare, including deterrence capability. The presence of advanced unmanned warships may act as a deterrent against potential adversaries, signaling a commitment to utilizing cutting-edge technology in defense operations. Enhanced situational awareness. Equipped with advanced sensors and AI capabilities, these warships will improve situational awareness, enabling naval forces to respond more effectively to emerging threats. Integration into joint operations. The killer whale program will likely facilitate greater integration within joint military operations, allowing for seamless collaboration between manned and unmanned vessels in various mission scenarios. 4. Challenges and considerations. Despite the promising outlook, several challenges must be addressed to ensure the successful deployment of killer whale technology. Cybersecurity risks. As unmanned vessels become more reliant on AI and connectivity, they will be susceptible to cyber threats. Ensuring robust cybersecurity measures will be critical to protect these systems from potential adversarial attacks. Regulatory and ethical concerns. The deployment of autonomous military systems raises ethical questions about decision-making in combat scenarios. Establishing clear guidelines and regulations regarding the use of AI in warfare will be essential to address these concerns. Training and personnel adaptation. While the technology will reduce the need for crewed missions, there will still be a need for trained personnel to operate, maintain, and oversee these unmanned systems. Developing appropriate training programs will be crucial for the successful integration of killer whale technology into naval operations. 5. Conclusion. In summary, the deployment of killer whale unmanned warship technology by 2025 is expected to revolutionize naval operations, driven by significant advancements in AI and autonomous systems. With a structured four-phase integration plan and a budget allocation of $150 million, this initiative will enhance naval capabilities, operational efficiency, and risk mitigation. As the military landscape continues to evolve, the killer whale program will not only redefine naval warfare but also set the stage for future advancements in defense technology. The anticipated benefits, including increased operational range, cost efficiency, and strategic advantages, will position naval forces to address emerging threats in an increasingly complex global environment. However, addressing the associated challenges will be vital to ensuring the successful implementation and acceptance of this groundbreaking technology.